Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to construct a frequency distribution, and we're going to graph it, and we're going to use that graph to estimate a percentile rank of any data point. So let's get started. Now this is a bit of a review, but it's going to come in handy as we understand this idea. So the first thing I would like to do is make a dot plot of this data. So I'm going to do that down here. Notice I have a data set that goes from 0 to 9, it looks like. So let's start here. We'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll put a 10 on there. Won't need it though. Okay, and now you can go ahead and I'll put a -1 on there in case. 1, 2, let's number it. 3, 4, 5, 6, 7, and 8. So I'm going to go ahead and make my dot plot, and take a moment. You can pause the video or just work along with me. I'm going to do it at a pretty steady pace, but here we go. I'll read the numbers off to you if that helps. So our first three are, it's going to go, we're going to put a dot over 3, then we're going to have 1, and then a 4, and then we keep going. So now, remember, we put another dot, we come to another 1, so we put another dot over the existing one. So 1, and here we go. 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 8, 3, 4, 6, 2, 6, 4, then 3, 3, 8, another 3, then 2, 7, 2, 7, 9, 5, 0, 2, 8, 4, 1, 9, 7, 1. And there it is. That is a dot plot for this data set. Now, what we're going to do is we're going to have 5 classes for our distribution. So so 5 classes. So now remember, you could easily estimate that just by playing around with separating the dots nicely like we've practiced. But we also have the range here. And notice the range of this is our high minus our low. And our high in this case is 9. Our low is 0. So our range is 9 if we want 5 classes. So then our width is going to equal 9 divided by our number of classes. That's 1.8, and we always said that we round up, so our width is 2. And we round to the same unit as our data. So our data is in whole number, our class widths would also be in whole number. So our width is 2. So if I grab another color like this pretty light blue, remember what we're going to do is we're not going to go down to -1, because if I have a class width of 2, then I would go up to +1. Well, if I put a line on the 1, I would split the dots. And remember, no dots die in the making of a dot plot or a frequency distribution. So we always split the difference between whole numbers. We go down to halves. These are in tenths. We'd go to half of a tenth, or 5/100ths, and so on. So here we go. So our class widths are going to look like this. 3.5, we're going to have some 5.5. Now you could use it 7.5 and even 9.5. You could use this information to construct a histogram, but today we're going to make our frequency distribution. And so here's what we're going to do. We're going to have our class. And notice that we're going to use boundaries. So I'll write that. I'm going to abbreviate it, BN, class boundaries. We'll write our frequency, and then we're going to write our cumulative frequency. Those are my abbreviations here. So let's construct. Now what we're doing is we're building our frequency distribution. And since we're including cumulative frequency, you could even call it a cumulative frequency distribution. Okay, so our first class is from minus 0.5 to 1.5. The frequency is 5, so our cumulative frequency at this point is 5 data values. Our next class starts at positive 1.5, and it goes to 3.5. In there, oh my gosh, we have a lot. 1, 2, 3, 4, 5, 12. Looks like we have 12 values. 12, so our cumulative frequency now is 5 plus 12 for 17 data values. So cumulative means that once you've gotten to 3.5, you've accounted for 17 values of the data set. Our next class goes from 3.5 to 5.5. And in our next class, it looks like we have 8 more data values. So it puts us up to 25 for total or cumulative frequency. From 5.5 to 7.5. Let's see, 5.5 to, oh, that's our, oh, I see, we only have 6 in that one. 6, so that's going to be 31. And our last one, look at where our last one, 7.5 to 9.5. And it looks like we have 4, 8, 9. Wow, that's a big one. And that is 40. And notice that that 40 is important because if you look at our data set, we have 4 rows. And each row has 10 data values in it. So that's our 40 values. If that number 40 didn't come, we knew we made an error somewhere. And we'd want to go figure out where that was. Now, what we're going to do is we're going to use this table, this frequency distribution in this tabular form. We're going to make it into graphical form. Okay, here we go. Let's graph this. So remember, this is tabular form here. So I'm going to grab another color. This is frequency distribution. This is in tabular form. Or table, tabular form. All right, so now let's graph it. The graph, and we're going to do a graph of cumulative frequency. Cumulative. And there's a reason for this, cumulative frequency. Okay, and I'm going to just give you some guidelines. I'm giving both of us guidelines. On our horizontal axis, we're going to put our class boundaries. Our vertical axis, on the vertical axis, we're going to put the cumulative frequency. Okay, and so let's do that. Now notice a few things. Notice our cumulative frequency is going to go to 40. So that could get a little long. We'll probably use a scale of 5. But I think our class boundaries should work out pretty well. So here we go. You can always adjust it if we need to. So, and then let's do our vertical one. Didn't do so hot on making those intersect, did I? Let's fix that. Okay, there, that looks better. So let's graph it. So here's this is our cumulative frequency on the vertical axis. We'll have boundary class boundaries. So let's take a look. So our class boundaries are negative 0.5. We have 1.5. 3.5, 5.5, 7.5, and finally 9.5. And I might use the rest of that in a little bit. And then let's graph our vertical. So we'll go 5. So we'll go 5, 10, 15, 20, 25, 30, 35, 40. Oh, that looks like it's just going to fit. I like that. We'll just put numbers in as we need them. Oops, as we need them. Okay. Oops, 15. So now what we're going to do is we're going to think about that dot plot we had in a little bit. So I want to go back to that picture. We're going to do a little bit of thought process here. So here's my dot plot, and I'm going to grab another color because we need to draw on it a bit. And what I want to show you is this. Actually, I'm going to do it this way instead. Okay. And what I want to show you is this. Notice that between, here's negative 0.5 and here's 1.5. Now we're thinking cumulatively at this point. So when we start at negative 0.5, we've accounted for none of the data values, 0. But by the time we get to 1.5, by the time we get to 1.5, if you're thinking cumulatively, we have accounted for all 5 data values in that bin. But then when we started our next class boundary, our next class starts at 1.5. Well, it starts at 1.5, but then it ends at 3.5. Well, at 1.5, we've only accounted for what's in the previous bin, 5. But by the time we get to 3.5, we've accounted for everything that's in the previous 2 bins. So we're at 5 when we're at 1.5. By the time we get to 3.5, we're at 5 plus this additional 12. So we're at 17. And that's how we keep that's how we keep track of what we're doing. And notice the big key is that we're starting down here at 0 dots, because our first class boundary, there's no dots down there. All right, here we go. Let's turn this off, and let's go back to our screen. So let's graph those. So at negative 0.5, we said that we're at 0 dots. So then at 1.5, we said, well, by then we've accounted for 5 dots. So here's what I'm going to do. From 1.5, I'm just going to go up with a little vertical line. And then from 5, I'm going to go over. I'm going to put a dot there. Now we need to pause here. That first dot, our second dot actually, is it's called an ordered pair. And what the ordered pair is it's written this way. It says that first dot has a horizontal position of 1.5. It has a vertical position of 5. For example, our first dot, it had a horizontal position of negative 0.5, but it has a vertical position of 0. And so our third dot, let's take a look at our third dot. So our third dot is going to have a position now of 3.5, but now we're thinking cumulative frequency. So by the time we get to 3.5, we've accounted now for 17 data values. That's what we're using this third column in our table. So that's going to be 17. And then our fourth dot, well, that one's going to be at our next boundary. Our next boundary is 5.5. But remember, by the time you get to 5.5, you've accounted for all of the data values before that. That's 25 data values now. And then similarly, our fifth dot, we'll have a fifth dot. Our fifth dot is going to occur at the next boundary of 7.5. Well, at 7.5, we've accounted for 31 dots, 31 of these dots. And our last dot, our sixth dot, is 9.5. And at that point, we have accounted for all 40 dots. These are ordered pairs. They're always written in the order of this of horizontal and the vertical. If you've taken an algebra or a calculus class and maybe graphed functions, then you may have seen this before. It's the same notation. Those are the same ideas of the ordered pairs there as well. These subjects tend to build on each other. All right, let's continue putting our dots. So we've done our first dot, the second dot, our third dot. Well, it says at 3.5 you're going to you go vertically. You just need to go high enough so that you can come in from 17. Now let's put some more numbers here. 15, there's 20, 25, 30. 35. Now, if I have to break this up, let's grab another color. 17 is probably 1, 2, 3, 4. So 17 would be right there. Oops. Where those two lines intersect, that is that ordered pair. So we'll put a 17 over there. And let's say our fourth dot says we go up from 5.5. And then we're going to go in from 25. And where those two lines intersect, we put another dot. And then we keep going. The next one says we're going to go up from 7.5. We're going to go up from 7.5. And we're going to come in from 31. Well, we're getting up here now. 1, 2, 3. Okay, so we're coming in here from 31. Coming just a straight, perfectly horizontal line. Put our 31 over here. And another dot where those two lines cross. And our sixth dot, we're on dot 6 now, is 9.5. So we're going to go up from 9.5. I always kind of overshoot it. I know I got to get to 40. 40 is going to come across right here at the top. There it is. Look at that. And there is my 40. Now, there's something we need to do. And this is the most exciting part. And at least I think so. Show that we connect the dots. I know this is like dot to dot when you were a kid. So you just connect the dots. You connect the first dot to the, let's get a better color than that. Let's do this pretty yellowy color. So you connect the first dot to the second dot. The second dot gets connected to the third dot. Third dot, that gets connected to the fourth dot. It's almost sounding like a song. The fourth dot gets connected to the fifth dot. And the fifth dot to the sixth dot. And there it is. That is the graphical form of a cumulative frequency distribution. Now, let's not lose sight of our goal today. Our goal, I'm going to go highlight it, was one, to make the cumulative frequency distribution. We did that. Here's what remains. Now, I didn't write a word in here, but at this point, we can just estimate. So we're going to do that. We're going to estimate a percentile rank. But what we've done is we started with what's called a discrete data set. All the data were in whole numbers. So all we knew is 0 through 9. But what if the question was, well, what about if we had a data value of a half? So a half, well, look at this. Here's the data. Oops, let me go back to my pen. For example, here's the value of 1. Well, a half, oops, probably is not right there. So here's 0, there's 1. But now, according to this, I could also look at data values like a half. That'd be between 0 and 1. Well, if I did the same thing from a half, I went straight up. And then to that dot, I went and made a horizontal line. The question is, right there, what would that value be? I'm not sure at this point. But what we could do now is we could estimate what the cumulative frequency is of any number. It could be a half, it could be 0.2. Any number that's in what we call the domain. And the domain is this stretch of numbers from negative 0.5 to 9.5. And so we say the domain, so we can just estimate within the domain of the data of the class boundaries. Domain of the class boundaries from negative 0.5 to 9.5. And in there we can estimate. So let's come up with one. I'm going to pick up another one here. This is also in our notes. Here's like value 6 and here's 7. And let's just be crazy. Let's just, sometimes you just have to venture out. What if I wanted to estimate the percentile rank of 6.2. That's right there. Well, let's do that. So it's the exact same process. Remember, we just said, well, let's just go up from 6.2. And where 6.2 crosses the line, that's our dot. Well, the question is if we come back with a perfectly horizontal line, and my graph may not be perfectly aligned, but yours probably is better, that question mark is the cumulative frequency of 6.2s. And what have we done? We have taken a discrete data set and turned it into a continuous data set. In other words, we can now deal with any possible data value. The gravity of it may not quite be clear yet, but it will be where we spend the last half of our semester looking at what's called continuous data sets. So, but we've now taken, I'll repeat it one more time, a discrete data set and written it as a continuous data set, and we can use it to estimate percentile ranks. So here we go. So it looks like now that question mark, so notice that the question mark is probably, it's somewhere between 25 and 30. It's a little below half. If you were a chemist or physicist, you might argue significant figures that the best you could do is say, well, the only number between there is 27 and a half. We'll just say it's probably about 27. It could be 26, 27 and a half, who knows? It's just an estimate, and then that's a pretty good guess. So if I wanted the percentile rank, well, what percentile rank would equal, it's going to equal to 27 divided by the 40 times 100 times 100%. And if we do that, let's go, I have a calculator ready to roll here. So let's take our 27. We're going to divide that by 40, and then we're going to multiply it by 100 to get our percent, 67.5. So let's go back. So we would, and now I shouldn't use equals, I should use a squiggly here. So our percentile rank is about the 67.5th percentile. So what have we done? Quick review. We started with a discrete data set. We turned it into a continuous data set. We graphed it. That allowed us to estimate the cumulative frequency of any value in the domain, which are the lowest class boundary to the highest class boundary. And then from there we can estimate the percentile rank of any value in the domain. I hope that helps, and thanks for watching.